Hello guys, myself Sheikh Basha. I am from mechanical engineering. My rule number 2295580 314. My tech talk is based on solid mechanics and my topic is non-linear deflection analysis of helical springs in elastic. Perfect plastic materials application to plastic extensions of pinion wire springs. Introduction. Flexibility is sometimes needed, and the springs are designed to fit the designer needs for carrying load with elastic deflection displacement. The slope of linear load deflection relaxation is given by the conventional formula for spring constant k is equals to gd power 4 by d 8d power cube n, where d small d and capital D are wire and coils, radians, n the number of turns, g the shear modulus. Non-linearity would appeared in load deflection relations of helical springs when the deflection becomes large. One origin is the geometrical non-linearity, which is termed pitched angle effect. Is classical work. In classical work, note that the above springs constant is obtained by considering only the torsion of spring elements due to external load. The approximately may be current for small deflection of closely pitched springs. The separately pitched springs, however, the deflection due to the beings of springs elements cannot be ignored. Moreover, the combined deflections of torsion and bending would occur in any springs when the deflection becomes large. Another geometrical nonlinearity comes from the rotation of a free end under load. The free rotation has been known to occurs and the elastic analysis was given when the end of a spring is fixed not to rotate, and a certain amount of torque should be subjected to the end. The magnitude of the torque and increases with increasing the deflection of spring. Present study considered the free to rotate and in order to simplify the boundary conditions of the analysis. The other origin in the materials non-linearity due to plasticity in metals and alloys. The plasticity of spring is particularly used in the cold steel setting operations, and the wide criticism was dissociated since from a study were considered with the elastic limit. Present study shall derive the load deflections relations in plastic range. Such the theoretical arrangement of plasticity may be of significance not only because of the advance in continuum machines but also possible applications to material capable of restoring large elastic deflections, such as shape memory alloys and some kinds of polymers. As for modern technology, shape memory polymer micro springs have been fabricated by the novel 3D by 4D printing. This study examining plasticity under the approximation of first curvature effects, non-curvature effect in the assumption of large springs in the index, which is the ratio of spring radius to element wire radius, and second, the elastic perfect plastic material. These are for the Beware in developing a formula. The formula was applied to non-linear load deflection curves in plastical, plastically extend helical springs made of pinion wires. It is because the wire, after approximately heat treatment, is deformed plastically with a small works rate hardening rate, which may be close to elastic perfect plastic one. In principle, any realisity material can be denoted with by some numerical components computations. Present present theory may work for giving more per, perspective to understand the nonlinear phenomena. S- Section splitting symbols and units. RD spring radius and diameter in mm. R not D not initially coil radius and diameter in mm. P radius of curve of element in mm. D element diameter in mm. N numbers of turns. L length of helical element per true before deflection. Delta dou deflection per true in mm. Turn in mm. Pi angle per turn around spring axis in a radius or dig. P load on a spring in n. T torsion moment in newtons meters. M bending momentum in newton meters. Delta pitch angle in rad. T not shear geometry of helical springs. Has it used to assume the length of spring elements in unchanged during a deflection, since the actual strain in negligibly small. The length per turn in the nature length L is equal to 2 pi r naught in figure 1. Is helical with the radius r equal to the radius of the tangent cylinder with the element diameter is ignored. The helix line with the pitch angle alpha is the rectangle 0 O minus x1, x2, x3 coordinate in x1 is equals to r cos theta, x2 is equals to r sin theta, x3 is equal to r theta tan alpha. Since the length of the element is d theta, method materials and methods. The phenomena wire SWP, a graph of JIS of diameter 0.5 mm was used. The where straight wire as annealed at 350 degrees Celsius and was tensilely tested at room temperature, which an in certain type testing machine. SEMDOS DSS 500. The stress strain curves of the spearman with the gauge length of 100 mm is shown in the figure 5. The elastic limit in indicates the elastic limit indicates by an arrow. The elastic limit indicates by an arrow was at 6, 1680 MPa, and the flow stress was above 2000 MPa. The elastic perfect plastic module, the elastic perfect plastic model was for the present calculation in is drawn by the dotted line in this deflection of phenomena wire springs. Load load weight was subjected incorrectly to springs, has illustrated in figure 6. One end of the spring was fixed to regained bar, and the another was clipped to the cage, which can carry a few pieces of weight. Has a weight was added to cage. The displacement of the cage and its rotating angle were measured simultaneously. A protractor was placed beneath the gauge. The angle of rotation was large enough to measuring by eyes with a proportional. The phenomena where spring was extracted up to the weight of P. Conclusion. The nonlinear load carrying capacity of helical springs made of elastic perfect plastic material was examined. A machines of material theory was provided by accounting for the combination state of torsion and bending in plasticity under the approximately of large spring index. The moving boundary problems for problems for tracking the moving while lows during the plastic torsion was solved. The explanation for of the solutions for elastic perfect plastic material includes the elevation integral. It was shown that. Thank you.